Hey everybody, welcome to Custom Build Studio. Today, I'm going to walk you through one of the easiest and most powerful tool for 3D design. It's called Onshape. Whether you're just starting out in CAD or you're switching from another platform like Fusion 360. This video will guide you step by step to help you build your first solid model using only your web browser. Onshape is a cloud-based CAD software. That means you don't need to install anything. Just open your browser, log in, and you're ready to design. It works on your computer and on your iPad and on your tablet, on your iPhone, on your Android phone if you want to view the model on the go. It's completely free for personal use and educational use, and it also gives you access to all the tools you need for sketching, 3D modeling, assembly, and even you want to export your 3D model for 3D printing. Onshape is great for collaboration. You can work on the same model with your team in real time, and just like Google Docs, but for CAD. Let's dive right into it. This is the Onshape login page. If you don't have an account yet, you can sign up quickly. It's simple and free, but since I already have an account, I am going to log in and get started. Now we can start a new project. I have created a folder shop education. Now we can create a file here. Before we create a new project, let me show you something useful about the free account. When you are using a free plan, all your documents are public, which means everyone can view them. If you go click a public tab, you can browse hundreds of designs made by other users. You will see the model preview and the owner name and even search for specific design. Just keep in mind, any file you create in a free plan will also be visible here unless you upgrade to paid account. Alright, let's create our first project. Click on create and then document. I am going to name this project printer accuracy test. And I will be walking you through the entire process from start to finish. This is a simple beginner-friendly model design to help you get started with Onshape. It includes a few basic features and design elements, nothing too complicated. So it's perfect for learning and testing your 3D printer accuracy. Let's click create and we are in. This is your main design interface. At the top, you will see the toolbar. On the left is the feature tree. You can zoom in and out by using a scroll wheel on the mouse and rotate the view by clicking the mouse wheel and dragging. In the top right corner, there is a view cube. You can click it quickly, switch between front, top, and side view, and more. And just beside that, there are some camera and render settings. One of the most useful tool here is section view, which let you cut the model to let you inspect the inside. We will use that later. Let's start by creating our first sketch. Click on the sketch and then select the top plane. You will notice that the camera does not move automatically to the top plane. That's okay. We have two options. We can click on the view cube and then the top. The second option we have is on your mouse, right click and choose view normal to the sketch plane. This option comes in handy when you have a plane which is at the angle. You can always select that plane, right click and choose view normal to the sketch plane. Now that we are looking straight down at the plane, let's begin our first sketch. We will use center point rectangle tool to design a square starting from the origin. I prefer working in inches, but Onshape is really flexible. You can mix and match units or even type math equations directly. For example, if you go to extrude, and now if you want a thickness of 5 layers and each layer is 0.2 millimeters, just type 0.2 times 5 and Onshape will convert it into inches for you. It shows the math and the result when you hover over the value. Super handy. If you want, you can change the default unit system. Go to Account, Preferences, and go down to Units and pick that works best for you. And just below that, there is a mouse control. I usually like the SolidWorks, but you can choose whichever you want to rotate, pan, zoom, and much more. Now let's go back. I will change the dimensions to 4 inches by 4 inches. Then hit extrude. Let's say ½ inch and hit OK. Now we have a basic 3D cube. I will clean up the workspace by hiding the planes. Just click the eye icon next to them in the feature tree. Now we have a square which is 4 inches by 4 inches. This square will be our base to test accuracy for X and Y axis. Now we need a circle. So I'm gonna click on a sketch and the top face. Then rotate the view to normal to the sketch plane. Use the center point circle tool to draw a circle from the center and set the diameter to let's say 2.5 inches. Now extrude it to the height of, let's do it 1/4 inches, 0.25 inches. So far we have added a block and raised a circle, both great for external features. Now let's add some hole to test internal dimension and shrinkage. I'm gonna select a sketch, top plane here. So I'm gonna show you two ways. First, I'm gonna show you the regular way. We will use more parametric approach. I'm gonna delete all 4 of these holes. For that approach, we only need one hole, right? And I would like to give a dimension from center to center of the hole, so I can control it, because that's what I'm gonna check once I have the holes. I'm gonna 3D print it, and I'm gonna check from center distance to center distance. If that's exactly what I needed, then my shrinkage compensation is basically 0. I am gonna draw a construction line from center to center. So you can use shortcuts. So one thing another I like about the Onshape, if you hover over line, it's gonna show you the shortcut, which is L. For the case of construction, it is Q. So now we have a center line. This is gonna help us to mirror the holes. So now go to mirror command, select the first line, and then select your entity. Same thing, select, you need to exit out of this. Now these holes are controlled equally. I'm gonna press D, dimension this 2.75. I'm gonna do the same for this 2.75. So now we have 4 holes. Press on extrude or shift plus E. Then click on remove and select through all. Press OK. Now we have 4 holes. Here is a pro tip. 3D printer tend to leave a seam where it starts and ends. That bulge can affect the accuracy of the hole. To avoid this, we can actually design a seam for a slicer to where it need to start and end. So I'm gonna go to my sketch. You know what? I'm gonna use my existing sketch of the hole. Go to top. I am gonna draw a line, and I'm gonna draw a center line here. I am gonna give the center line 45 degrees. I'm gonna use mirror, a vertical line, and select my entities. Escape, and I'm gonna do the same for the horizontal line. So here we go. Select OK, and yeah, there we have a line where it's gonna start and it's gonna end. So we gonna avoid the bulge. The next step is to have X and Y letters on the X-axis and on the Y-axis to help us identify the orientation once we print. In Onshape, go to this text icon and place a square anywhere you want, right? In this case I want it here, and press whatever you want it to write, in this case X, right? Press OK, and we're gonna do the same for the Y-axis, and press Y. It does not matter how big you want this to be at this point, and press OK. You can also select what font you need, and bold, italic, and you can flip it horizontally and flip it vertically. We're gonna press OK. So we have X and Y. X orientation looks good. For the Y, I want it to face horizontally rather than the vertically. So what we're gonna do is select any one of these points. Don't select, but just hover over it. You'll see a constraint, or maybe on the line. Yes, you see that vertical constraint? I mean the horizontal constraint. Click on it, press delete. Now we can actually, it's free to move, and if I click on this point, it won't let me rotate, right? Because the whole thing, there is no fixed point around which it will rotate, right? So in this case, we select one of the point, any one. I'll select this, and I'll go to fix. Now we should be able to rotate it, around that point. And now just place it here, so it is kinda horizontal. Press on the horizontal line and just give it a constraint for vertical, right? There we go. Now I'm gonna delete this constraint of fixed. So now we have what we want roughly. Now we're gonna give it the dimension. So let's give this about 0.375 height, and same for the X, 0.375, and move this down right in the middle. Same thing for the Y. If you want this right in the middle, we can place a center line both in vertical and horizontal, right? Click on it, give it a constraint for horizontal, give this one as a vertical. So these are right in the middle, or roughly in the middle, right? So give this dimension from this circle. I'm gonna give it a point. We have two options though. We can give it a dimension from this side or this side. I prefer this side because we're gonna put a big chamfer on this side, right? So here, and give it enough so it won't interfere. I would go with 0.0, let's say 8. Same thing on this side. Oh, we gotta give it a point here. There you go. This to this is 0.08. So that looks good. If this is too small, we can always come back and give this as a big dimension. So go to extrude and height. I want to extrude this about 3 layers, right? So we're gonna do 0.2 millimeters time 3. So this is about 3 millimeters tall. Not 3 millimeters tall, but 3 layers tall. So that is good. So our model is almost done. So we have outside edges to measure our X and Y outside dimension. We have some holes from which we can check our shrinkage of the material, and also we can check the hole size. And we have the outside boss to check the outside circle diameter. Now let's make some inside square. So go to sketch. In this case, we can either select the top or the bottom. Let's select the top, go to top view, and make a center point rectangle. Give this a dimension. Let's make it 1 inch by 1 inch. Just simply extrude it to remove. Go all the way through and press OK. So we have a square inside. To measure it, the ID. Now we're gonna test the flow rate. So we can create a wall about, let's say, 0.5 millimeters thick, which is slightly thicker than the standard size nozzle 0.4. This helps us measure over extrusion or under extrusion. So click on sketch, top view, and we go to use project and conversion. Press click here, click here, click here, click all 3 lines, and we're gonna use offset command. So click on offset, click each line you want it to offset, and give this a dimension. So I want this to be 0.5 millimeters. Press enter, enter, and we have the offset lines. Now we can simply just extrude this. It's up to us how much we want to extrude. Let's just go 1/2 inch. It's good enough to measure it with our caliper. Alright, our model is almost complete. There's just one last thing we need to add, a way to check skew. Skew refers to a misalignment between our x-axis and y-axis. Ideally, they should be perfectly perpendicular to each other. Exactly 90 degrees. But if your gantry is slightly off, let's say 89 or 91 degrees, your shapes won't come out square. They will affect the hole positioning, square corners, and overall print accuracy. So how do we measure and correct skew in Klipper? Klipper requires 2 measurements. A straight line distance along x-axis, so from this to this, and in y-axis from this face to this face, and a diagonal or edge to edge distance, so from this edge to this edge, and also from this edge to this edge, which refers where the corner are actually end up. So the Klipper gonna determine if this edge distance is exactly what it's supposed to be when it's making perfectly 90 degrees corner. By comparing these, Klipper calculate how far off your gantry is from being square. It then use that to auto compensate for skew in your firmware. So let's start designing the skew checker in our model. So let's click on the sketch and use this plane, then go to top. We're gonna draw a line here, straight up, connect this to our model, and also create a straight construction line from the middle to the midpoint of this line. I'm gonna use project command to project this point, and I'm gonna attach this and this together. There we go. And I also want these two lines to be right in the middle or symmetrical to each other. They are. Now let's make them parallel to each other just to make sure if they are parallel or not. They are. So, and also we want this and the center line to be perpendicular to each other. And there we go. Let's make this flat about 1 inch. And now we're gonna attach this to right on the edge. So then we know that this flat point is right in the edge of these straight line where they meet, right? So we have something flat to measure on. So we're gonna do same thing on the other side at the 4 corners. We're gonna use a circular pattern command and start selecting our entities and make it 4 and click anywhere. Okay, as you can see, these are still blue, which means they are not defined. So I'm gonna click on any of these entities or any of these points and start dragging outside. So now I know our center point of these rotation are not fully defined. So I'm gonna drag this and snap this to the center point. And there we go. This is fully defined. The next step is extruding it out. So go to extrude. Click on all that we want it to extrude. And go to add and in the opposite direction. And also I don't want it to extrude from the top, because I also want a space to measure these straight line square with my caliper. So if I extrude this from all the way up, I won't have any space or proper space to measure with my caliper. So here what I'm gonna do is I am gonna use start offset feature. Click on this in opposite direction and make it 0.25. So it's gonna offset the start point about 0.25. And I wanna go to the up to a face, which is the bottom face. So here we go. We have a flat. So we can measure this skew from this to this easily without having inaccuracy in our measurements. To improve the print flow, we will add fillet and chamfer. So we're gonna start adding fillet just to smooth out the corner. It helps the printer to move more fluidly around the corners. So go to fillet. Always use fillet to round out any corners. So let's start with our holes. You see these sharp edges. This point, I want this to be sharp, so my printer knows where to start. So I'm gonna add fillet on these 2 corners. Same thing on this side. Here. So make this, let's say about 0.8 millimeters. 0.8 millimeters. That is enough. Let's make it 1. Let's make it even. Okay, there we go. So just a small, so it can just easily flow from this to this circle. So we have this here, and let's make a fillet on these outer corners. And these fillets also help a printer. Let's say make a fillet here. So it's gonna help our printer to have a smoother transition from this y-axis to our x-axis. If it was sharp, it would needs to come and stop and change direction. But if we put a fillet, it's gonna go down and it's gonna smoothly transition to the other axis. and that's what we want. So let's make all these edges rounded. Okay, so it has to be enough. Let's make it 2 millimeters. That is good. Let's make these corner also radius. It helps us do one more thing, because in 3D printer your sharp edges are not perfectly sharp because the nozzle size is not a point. It has a dimension, which in most of the cases is 0.4 millimeters, right? If we put a radius on, we avoid this blob on the corners, which can affect our measurements. If we put a radius on, then we can easily measure this across. So let's make it 2 millimeters, which is enough. So we have radius on all the corners except on this wall. Click here, it has to be very small. I believe we don't actually need this to be rounded, but we're gonna do it. So we're gonna give it a really small amount, let's say 0.8 millimeters. That is good enough in this case. So it's gonna just flow smoothly. Now let's start giving a chamfer. So chamfer help us avoid on the bottom. It's avoid us having an elephant foot where the first layer squeezes out and affect our measurement. And on the top, it's gonna help us same thing. Because our top layer gonna move faster to fill the top layer. Your extruder, if it's overflowing or over extruding, it's gonna bleed into the hole, and which also gonna affect our hole size. So we want a chamfer so it won't go past this line. So we have chamfer on the top, and also same thing on every single edge. It helps us also do one more thing. It also helps us to have a better transition rather than having a sharp edges. I'll show you what I mean. So here, if it's a sharp edge, we have a point of breakage. But if it just give us an extra material on the corner, now it's a better and a stronger edge, which have more material, so it won't break easily. So we have chamfer all around, press OK, and I think we're good to go, and it looks pretty. The bottom, and there we go. So we have our model now. Your 3D printer calibration model is complete. In the next video, I will show you how to slice print and measure this model, and how to apply this setting in your next project. Thank you for watching, and I'll see you in the next video.